We will start with our PYQs of kinematics. Okay, so let's start with our question number 1. Question number 1 says over here, a vehicle travels half the distance with the speed v and the remaining distance with the speed 2v. Its average speed. So we have to calculate over here average speed. We should know the formula for average speed. Our average speed over the complete journey must be equal to total distance whole divided by distance divided by the total time, correct? So if you divide the total distance with the total time, you get always the average speed, correct? So over here the particle is going from any point, let's say A, to any point B. Okay, in between it's splitting the whole journey at point C. While going from A to C, it is covering any distance x, and while going from C to B, it is covering distance another x. Why both of them are equal? Because it is given in the problem, right? So you are going from A to C and you are going from C to B. So if you are going from A to C and C to B in distance xx with the speed, the first half with the speed v and the second half with the speed 2v, right? As per the question, let's figure out the time taken. The time taken to go from A to C will be TAC, that will be equal to distance traveled, which will be x upon velocity v, correct? Now you are going from C to B with the distance x, so time taken while going from C to B must be equal to x upon the velocity, which is 2v, correct? Let me repeat again the whole scenario. The scenario says that a particle is traveling from A to C and then C to B. A to C is equal to C to B because the question says half the distance, right? It is half the distance. Later on we will see what happens in case if there is half the time, right? So here TAC and TCB are the time taken which we have calculated, and that will be different. Why they will be different? Though the distance traveled is same, but the velocity is different. So in case the velocity with which you are moving is different, the time taken to travel will be different, right? In each case. Okay, great. Let's come back to our relation. So average speed will be equal to total distance. What is the total distance? X and plus x, right? While traveling from A to B, the total distance traveled is x plus x. The total time will be equals to TAC plus TCB, right? We are going from C to B. Now x plus x, that gives us twice of x, and TCA or TAC, which is x by v. So let's substitute over here x by v plus TCB, that is x by 2v. I hope this is clear. Okay, I just substituted what is our time period while going from A to C and what is our time period while going from C to B, right? Now what we will do, now we will take common out. So 2x over here, and taking x common here, we left with 1 by v plus 1 by 2v, correct? And let's cancel out this x with this x. I hope this is clear. Now let's take the LCM in the denominator. So let me solve it over here. Okay, so let me just make a line over here and solving the next part here. So average speed over here will be equals to 2 whole divided by, taking the LCM, or you can say cross multiplication if you want to. So we can take cross multiplication also, 2v plus v whole divided by 2v square. I hope this is clear, right? I have taken cross multiplication. Now this 2v square will go up. Okay, so if you take 2v square on the top, this will become 2 into 2v square whole divided by 3v, and 2 into 2, that is 4v square whole divided by 3v. Let's cancel out this v with one of the v and we left with 4 by 3v, right? That's our average speed in the entire journey. So the correct answer is option B, 4v by 3. I hope this is clear. Let's see our next problem, okay, in the series of NEET PYQ. So our next question says, a person traveling in a straight line moves with a constant velocity v1 for certain distance x. Now certain distance x, it is moving with the velocity v1, right? And with the constant velocity v2 for the next equal distance. Okay, great. Now next equal distance, be very careful, the next remaining half is also equal. The average velocity v is given by what relation? Now in the previous problem also, what we have seen, that we have calculated the average speed. Okay, there is a direct relation also we can use. Okay, in case if you remember, average speed direct formula is 2v1 v2 whole divided by v1 plus v2. You can directly apply it in case if you remember this. In case if you don't remember this, let's solve this problem and understand the core concept behind this, right? So let's see what is the motion which is happening over here. A particle is going from A and it is traveling to any point. Let's say this is B and this is distance x. Now it is going from B to another point, let's say C, which is again a distance x, right? Okay. Now, when it is traveling from A to B, it is traveling with a velocity v1. And when it is going from B to C, it is traveling with the velocity v2, right? So velocity changes, and since the velocity changes, the time period also changes. So when you go from A to B, the time taken will be different from B to C, right? So let's calculate time taken while going from A to B. That will be equals to distance traveled while going from A to B, which is x, right? And the velocity, that is v1. And time taken while going from B to C, that will be distance traveled x and velocity v2. I hope this is clear, right? So we found the time for A to B, we found time for B to C, right? Now let's calculate the average speed. Now sir, what is the formula for average speed? Our average speed is nothing but total distance whole divided by total time, right? Total distance over total time, that is our average speed. Now what is the total distance over here? Now total distance over here is nothing but 2x, right? Why sir? X while going from A to B and x while going from B to C, whole divided by the total time. Total time will be, let me write it for you, TAB plus TBC. I hope this is clear, right? This will be the total time interval while going from A to B, time interval while going from B to C. Let's substitute these values. It will be 2x upon, now TAB. Now TAB is how much? X by V1, and TBC, that is x upon V2. I hope this is clear. This is our average speed. Clear? Be very careful. The average velocity or average speed in this case will be same. Sir, why average speed and average velocity in this case will be same? Because the particle is not changing the direction. If the particle is not changing the direction, the displacement will be equals to the distance, right? And in that case, average speed will match as the average velocity. Be very careful with this particular part, okay? So don't get confused in case if you are thinking that's why you are solving average speed formula and average, not average velocity, right? In case if the particle is not changing its direction, if the particle is moving in the same straight line, the displacement will be equal to distance and the average speed will be equal to average velocity, right? Okay, coming back to the problem. So here the average speed is given by v. So let me write here v, okay? And x cancels out. So you left with v equals to 2 upon 1 by v1 plus 1 by v2, right? Now let's take this bracket part on the left hand side and v on the right hand side. So if you take the bracket part on the left hand side, it will be 1 by v1 plus 1 by v2, right? And taking this v on the right hand side, it will go below the 2, right? So you left with 2 by v must be equals to 1 by v1 plus 1 by v2. Now that's our final result. Let's see if it matches. Yes, it matches option B. Clear? I hope this is clear. In case if you have any doubt, just go through it backward and rewatch the video. Let's see the next one. Great. Let's see the interesting part. Next problem. The problem says over here, Preeti reached the metro station and found that the escalator was not working. Okay, it was not working. So she walked up the stationary escalator in time t1. Fine. On the other day, if she remains stationary on the moving escalator, then the escalator takes her up in time t2. Fine. The time taken by her to walk up on the moving escalator will be how much, right? Okay, let me explain you the scenario. The scenario is, one day I went to the mall, let's say any mall I went, okay? What I found is escalator is not working. In case the escalator is not working, so I have to walk on the stairs, right? The stairs of escalator. So when I am walking, I have certain speed, right? And according to that speed, I will reach up on the top, okay? Other days, what happens when the escalator is working very fine, okay? No issue with the escalator. What happens is, it takes me up. When it takes me up, it has a certain speed. Now, the speed of escalator is different from the speed of me. When I am moving up, I have a certain speed. When the escalator is taking me up, it is having a certain speed. Okay. Now, the third scenario is a different scenario. In the third scenario, what is happening? The escalator itself is going up and I am also walking on the escalator. Let me repeat again. The escalator is going up and I am also walking on the escalator. In that case, what will happen? So let's see the all three scenarios. So let me start with the first scenario. In the first scenario, what is happening over here? That escalator is stationary and I am moving. When I am moving, I will reach on the top according to my speed. So whatever speed I have, I will move with that particular speed. So let's say my speed is, or Preeti's speed is VP, okay, VP, and she is traveling above the escalator. Let's say, what is the X? X is the distance it has to, or the height it has to travel, okay, that is our distance upon time t1, right? Now, what is the time t1? Time t1 is, as per the question, it is the time taken by Preeti to go up the escalator. Now Vp is the velocity of Preeti. When the escalator is not working, she will move with certain speed. Now that speed is Vp, and that is equals to x upon t1. T1 is the time taken by her. Second scenario. Okay, let me write it for you. Escalator not working. Escalator is not working, right? Okay. What's our second scenario? In the second scenario, escalator is working fine. So when the escalator is working fine, what is happening? Sir, I am simply going and I am standing on the stairs, and the escalator will take me up with its own speed. Now that time it is not my speed. So that time it is not Preeti's speed. It's the speed of escalator. So velocity of escalator will be equals to distance again same. It will take you to the same floor. Okay, when the escalator is taking you from one floor to another floor, it is taking you to that certain same height. Okay, it is not like when the escalator is moving, it will take you to any other level, right? So VE will be equals to x by t2. Okay, now this time the time changes, the distance remains same, but the time changes, and in that case the escalator is moving, right? So let me write here, escalator is moving or it's working. Great. Now these are the two scenarios. Okay, I'll show you some animation also in case. Okay, here we will see some animation also in both the cases, right? Okay, let's see later on what happens when in the third scenario, when the escalator is also working and Preeti is also moving. So it is like escalator is going up and I am also moving on the stairs. In that case, will I reach faster or will I reach later? I will reach faster, right? Why I'll reach faster? Because my speed will be added up to the escalator, right? So third scenario, what happens? Both the velocity of Preeti plus velocity of escalator will add up. Sir, why it adds up? It adds up because we both are moving in the upward direction. Quite different from relative velocity, right? Because I am the part of the system. So when I'm the part of the system, we both are moving with the same speed. And in that case, it will be moving the same distance x, and this time let's say she is taking the time t. Okay, let me give you a recap of whole scenario. In the first case, when the escalator is not working, right, when the escalator is not working, who is moving? Preeti is moving. And when the Preeti is moving, going from any point A to any point B, the distance x is traveled in time t1, right? Second case, when the escalator is working, Preeti is stationary. And in that case, only the velocity of escalator will take her from one point to another point in time t2. Time obviously will be different, right? Because depending on the Preeti speeds and escalator speed. In the third case, when both of them are moving, in that case, both the velocities will add up, right? So let's substitute both the velocities. Vp is nothing but x by t1 and Ve nothing but x by t2, and that will be equals to x by t. Let's cancel out all the x here and take the cross multiplication here. So t2 plus t1 whole divided by t1 t2, that will be equals to 1 by t. So t will be nothing but t1 t2 upon t1 plus t2. So this will be the time taken in case Preeti is moving on the running escalator. Be very careful. Okay, so I hope this is clear. Very interesting problem, PYQ from NEET examination. Let's see the next one. Okay, great. Let's see our next problem. So next problem says here, if the velocity of a particle is given by v equals to at plus bt square, where a and b are constants, then the distance traveled by it when between 1 second and 2 seconds we have to figure out, right? So what we have here is we have a velocity function v is given by at plus bt square. Great. We have to find the distance in the time interval t1 will be equals to 1 second and t2 is equals to 2 seconds, right? So in case if you are given with a velocity function and you have to figure out the displacement, our x is nothing but integration of v dt, right? While going from any time interval t1 to t2. I hope this is clear. So let's simply substitute over here v and figure out the value of x, right? So let me substitute here integration. T1 is nothing but 1, T2 is nothing but 2. Velocity over here is at plus bt square, right? dt. I hope this is clear. Clear? Now what I will do here is x will be equals to, let me just take substitute here, common a out, okay, because it's a constant, and here it will be 1 to 2 t dt plus, let me take here b outside, integration of t square dt while going from 1 to 2. I hope this is clear. It's a simple integration problem, right? So here it will be a integration of t, that will be equals to t square by 2 while going from 1 to 2. It will be b t cube by 3 while going from 1 to 2, right? Let me substitute the upper limit minus lower limit. So it will be a by 2. Let me put the upper limit 4 minus 1 plus b by 3. Putting the upper limit 9 minus 1 upon, okay, 3 we have already taken out, right? So 9 minus 1, right? Is it correct? No, it's 8 minus 1. Okay, so be very careful. 2 cube is 8 minus 1. Okay, so it will be 3 over 2a plus 7 by 3b. I hope this is clear. So this is 3 by 2a plus 7 by 3b. Option B is correct. Okay, so this was our correct and very simple, straightforward problem. Okay, from previous year's questions. Let's see our next question. Okay, great. Our next problem here says two cars P and Q starts from a point at the same time. Okay, fine. Both are starting at the same time in a straight line and their positions are respectively represented by XP. Position of the first car is how much? AT plus BT square. Great. And XQ, that is given by ft minus t square. Great. Okay, these are position functions, right, of both the cars P and Q. Okay, because they are starting at the same time from same point in the straight line they are moving, right? At what time do the cars have same velocity? We have to figure out the time at which both the car will have same velocity. Same velocity means Vp must be equals to Vq in this particular case, right? If Vp is equals to Vq, we have to simply differentiate here dxp upon dt. This must be equals to d by dt of xq, correct? Let's differentiate both. So differentiating xp, it will give you a plus 2bt and xq will be f minus 2t. Let me repeat again. I have differentiated at. Differentiation of at will give me a. Differentiation of bt square will give me 2bt, right? Differentiation of ft will give me f, and differentiation of t square will give me minus 2t, right? Minus because it's already there. Okay, what we have to figure out? We have to figure out what time they will have this condition to be true, which means at what time both of them will have same velocity, right? So let's take the t variable on one side. So 2bt plus 2t must be equals to f minus a. I hope this is clear. Clear? Now let's take 2t common here. So taking 2t common, it will be b plus 1 equals to f minus a. I hope this is clear. Now let's take this 2 and b plus 1 on the right hand side. What we left with here is t is equals to f minus a whole divided by 2 times 2 taking outside. It will be how much? B plus 1. B plus 1. I hope this is clear. This is our time period when the velocity of both the cars is same. So this is which option? The correct option, it seems, is option D. I hope this is clear. Great. Let's see our next problem. Our next problem says, here it is. A particle of unit mass undergoes one-dimensional motion. Okay, one-dimensional means it is moving along x-axis, or it may be along y-axis or along z-axis, but in a particular one direction. Okay. So one-dimensional motion says that its velocity varies according to our velocity function is given here. So let me write here Vx. It is given here as beta x to the power minus 2n. Great. So velocity is a function of position and not the position of time. Be very careful. Oh, sorry, function of time, not position. What I'm saying. So velocity here is a function of position and it's not a function of time. So you have to be little careful, right? Usually when you are solving problems on kinematics, we are given with displacement, velocity and acceleration function in terms of time. Here it is given in terms of displacement, or you can say position, right? Okay, let me come back to the problem. It says a particle of unit mass undergoes one-dimensional motion such that its velocity varies according to this particular thing, where beta and n, okay fine, are constants and x is the position of the particle. X is the position of the particle. The acceleration of the particle as a function of x will be how much? Okay, now we are familiar with two relations on acceleration. The first relation is a equals to dv by dt. I hope this is clear. Okay, rate of change of velocity with respect to time is acceleration. Along with this, we have also learned in kinematics that A must be equals to V dV by dx, right? V dV by dx. Okay, this is also something which we are familiar with. Okay, now sir, when to use which one? Okay, you are familiar here. If you look very closely, dt here represents time. So if you are having a velocity as a function of time, you use the first expression, right? If you're given with the velocity as a function of displacement or position, you will use the second one, right? So in this case, you can directly see there is no time over here. So what we can do, we can simply use the second function. So a is equals to v dv by dx. Let's figure it out. So acceleration must be equals to how much? It will be v dv by dx, right? V dv by dx. Okay, so we will make use of this. I hope you got a clarity that why we are using this particular expression over here. So let me substitute here v, because v is already a function of x, so it will be beta x to the power minus 2n, and here it will be d by dx of how much? Beta x to the power minus 2n. I hope this is clear, right? The first part is simply the velocity over here, okay, and the second part here we are about to differentiate it, right? Okay, let's move ahead and see our differentiation part. So this will be equals to beta x to the power minus 2n. This is the velocity part initially. Now let's differentiate the second one. Now when you are differentiating, beta here is constant as per the problem. So if beta is constant, we can take it out of the differentiation. So let me just write it as beta as it is. X to the power minus 2n, x to the power something, differentiation will be, sir, power will come in the front and the power decreases by 1. So it will be minus 1. I hope this is clear how I got, okay, how I got this part. Right? I simply differentiated x to the power minus 2n. So 2n came in front and x to the power minus 2n minus 1, right? Now let's take here in front rest of the things. So beta into beta, it will become beta square. Great. Minus 2n. So let me just write, because it has a negative sign, no? Let me just keep it in front here, minus 2n, right? Okay, so minus 2n is done and beta is done. Beta multiplied with beta became beta square. Now let's multiply x to the power minus 2n and x to the power this. X to the power something and x to the power something, x to the power will add up, right? Minus 2n and minus 2n, it will become minus 4n. And minus 1 was already there. So this will be the result. Okay, this is our acceleration we were looking for. Clear? Let's see if there is any answer which looks quite similar to this. Yes, option B is looking like this. So minus 2n beta square x to the power minus 4n minus 1, right? I hope this is clear. Let's see our next problem. Okay, great. Our next problem says here, the motion of a particle along a straight line is described by equation x is equals to this. Okay, this is our position or displacement of the particle, you can say, where x is in meter and t is in second. The retardation of the particle when its velocity becomes 0. We have to find the acceleration basically. Negative acceleration is known as retardation. So you have to find the retardation of the particle when the velocity is 0, right? And what is velocity? Velocity is dx by dt, right? So let me write it for you. V is equals to dx by dt. V equals to dx by dt. I hope this is clear. So let's differentiate this part. So it will be d by dt of x, which is how much? 8 plus 12 t minus dq. Let's differentiate it. It becomes 12 minus 3t square. This is our velocity function, right? Okay. Now what's the question is saying? Question says when the velocity becomes 0. So let's substitute here. V becomes 0. So putting here it as 0, it will be equals to 12 minus 3t square. Let's take this 3t square that side. It will become 12 here, and t square will be equals to 4 and t will be equals to 2 seconds, right? Time can never be negative. So you got t as 2 seconds. But they are not asking the time, right? What they are asking? They are asking the retardation. Okay, retardation means negative acceleration. So let's figure out the acceleration first. So differentiating this, dv by dt, we will get what? We will get acceleration A or retardation, right? If it is negative, it's a retardation. If it is positive, it's acceleration. So let's differentiate this. So putting here d by dt of velocity. Where is velocity? Sir, velocity here is 12 minus 3t square, right? Velocity is 12 minus 3t square. Now differentiating this 12, this will give you 0 and minus 60. I hope this is clear. That will give us minus 6 times t. Now what's the time we got? So 2. So let's substitute here. That will be minus 12 meter per second square. Now be very careful, this is negative, hence it is retardation. So correct answer, the magnitude will be equals to 12 meter per second square. I hope this is clear. Clear? Let's see our next problem. Okay, our next problem, quite interesting problem. Based on vectors you can solve it, okay, very easily. So problem says a body is moving with the velocity of 30 meter per second towards east. So let's say that it is moving in this direction with 30 meter per second towards east. Fine, okay. After 10 seconds, so let me write here, time is given, its velocity becomes 40 meter per second towards north. So its velocity becomes 40 meter per second towards north. Okay, I'm just assuming that on the left hand side, on the right hand side it is east, on upward direction it is north, right? And this transition is happening after 10 seconds, right, as per the problem. The average acceleration of the body. So before we calculate our average acceleration, first of all let me write our initial velocity. So our initial velocity, I am assuming it is 30 I cap, right? What is I cap? Along the right hand side, positive x-axis. Similarly, we can think of as 40 j cap. I hope this is clear. Final velocity is 40 j cap, and this is happening in 10 seconds, right? So acceleration will be equals to magnitude of v minus u whole divided by time taken, right? So v is how much? V is nothing but 40 j minus 30 I cap whole divided by 10. I hope this is clear. Now we can find the magnitude, 40 root under 1600 plus 900 whole divided by 10. Okay, I hope you know how to figure out the magnitude of a given vector. Okay, root under a square plus b square, right? So that will give me how much? Root under 2500 whole divided by 10. I hope this is clear. Yeah. Now root of 2500 is how much? 50 upon 10, and that is equals to 5 meter per second square. I hope this is clear, and that's option C. Okay, this is the average acceleration of the particle. I hope this is clear. Let's see our next question. Okay, our next question is over here. It says a particle moves a distance x in time t according to the equation this. So let me write the equation for you. X is equals to t plus 5 whole raised to power minus 1. The acceleration of the particle is proportional to, we have to find the proportional to, means we are not find, we don't have to find the exact equal, we have to just figure out the proportionality part, right? So first of all, to find the proportionality part, let's find the velocity. So velocity will be equals to dx by dt, right? That will be minus 1 t plus 5 whole raised to power minus 2, right? Simply minus 1 will come in front and t plus 5 whole raised to minus 2, right? And differentiating t plus 5 by chain rule, it will give you 1. I hope this is clear. Again, a will be equals to dv by dt. So if this is the velocity, let's differentiate this. So minus minus it becomes 2, and this will become t plus 5 whole raised to power minus 3. I hope this is clear, right? Now this is our acceleration, this is our velocity. They are saying which of these this is true, right? So let's start with the first part only, velocity to the power 3 by 2. Let's see if velocity to the power 3 by 2 gives us acceleration or not. Be very careful here, they are talking about proportional, right? So when you're dealing with proportional, you don't focus on this numbers, constants, right? So we have to just look at the factor. So velocity, let's start with the first part, velocity to the power 3 by 2. So let me just take t plus 5. I'm ignoring the negative sign. This negative sign I'm ignoring. I'm just writing t to the power minus 2 whole power 3 by 2. Right? This is our velocity, whole power 3 by 2. So 2 and 2 cancels. We left with t plus 5 whole power minus 3. Are we getting our acceleration? Yeah. Correct? So if you simply take velocity and do the power 3 by 2, you get the acceleration, right? So simply our option A is correct. Clear? Sir, what about the negative sign? Again, I'm repeating, it is assumed to be constant, right? This 2 again constant. We are looking for proportional because they are saying the acceleration of the particle is proportional to which one? They are not saying it is equal to what, right? So be very careful with this particular thing. I hope this is clear. Great. Let's see our next question. Our next question says a particle moving along x-axis has an acceleration f at time t given by f is equals to this, where f naught and t are constants. The particle at t equal to 0 has 0 velocity. In the time interval t equal to 0 and the instant when f equal to 0, the particle's velocity we have to figure out. Okay. In case if you have not understood the problem, let me explain the problem to you first. Okay. So problem over here we have seen, it says that f is our acceleration. It is given by f naught 1 minus t by t. Okay, this is our acceleration. So let me just write, instead of f, I am just writing it as a. This is our acceleration, and we have to figure out our velocity. To figure out the velocity, what you have to do, sir, we have to integrate it, right? So if you integrate the acceleration, you get velocity. So v will be equals to integration of a dt, and that will be equals to integration. A is how much? F naught. Let me just multiply this f naught with this and this. Let's do it. So this will be f naught minus f naught t upon capital T dt. I hope this is clear. Let me repeat again. As per the problem, this is our acceleration given over here. This is our acceleration. So if I multiply this f naught with 1, I get f naught with t by t. This will be f naught t by t, right? Now let's simplify it further, integrate it. So on integration, our velocity function, we get it as integration of f naught. So f naught is a constant as per the problem, so we got t here, right? I hope this is clear. Now here f naught and this capital T both are constants. T, this t on integrating will give us t square by 2. So this will be minus f naught by t square by 2. I hope this is clear. Okay. And on integrating, we get a constant also. So plus c, right? This is our velocity function after integrating this acceleration. Now what they are saying, it says the particle at t equal to 0 has 0 velocity. So if I put t as 0, velocity is 0, so constant becomes 0. Okay, I hope I got our velocity function as this. This is our velocity function after integrating that. Okay, great. Now let's see the next one. In the time interval t equal to 0 and the instant when f equal to 0, the particle's velocity. We have to find the particle's velocity when f is 0, right? So first let's put here in our main equation, which is this equation, we have to put what? F as 0. So at f equals to 0, what's the value of t? So let me write here f equal to 0. 0 equals to f naught 1 minus t upon capital T. Taking this f naught on the left hand side, it becomes 0. So this will be 0 over here equal to 1 minus t by t. Great. And taking this that side, it will be t by t equals to 1. And our here small t, the time is nothing but capital T. Okay. We got here. This is a very crucial outcome. So f is 0. When f is 0? When small t is equal to capital T. And at that particular time, we have to find the velocity. So let's substitute this small t as capital T in this particular expression, right? So v will be equals to f naught. What is small t? So small t is capital T. And this is the velocity at what time? At this time, when f is 0, right? So this is a particular velocity, a unique value of velocity. This is a general function of velocity, right? Ft minus f naught upon t square by 2. I hope this is clear, right? Let's cancel out this t with one of the t and be left with f naught t minus f naught t whole divided by 2. And that will give us how much? F naught t by 2. That's our velocity in this particular problem. So our correct answer is half f naught t. That's option D. I hope this is clear. We'll continue with more set of problems in the next lecture.